Hi everyone, welcome to part 5 of the video tutorials for Woodbee. We are creating toolpad for CNC and robotic milling from Rhino Grasshopper. In the previous video, I talked about the adjusting speeds, uh, different type of feeds and spindle, which you can set for your for different parts of the toolpad and control how fast the tool engages, work, or retract from the material. In this video, we're going to continue improving our toolpath by changing the different properties like depth of cut and deploying different strategies. In order to modify a toolpath, we have to adjust what comes out of our planar sheet component and override those default settings. So what you see here is all created using this planar sheet component, and if I just drop a panel in front of it, I can see that I am getting three operations, and the first two are uh, parallel contouring and two-dimensional, and there's a little description over each in front of each operation which tells you what is actually doing. It's using this strategy to cut the outer loop of the raw part, and that's what you see in the viewport. We basically create a loop around each part, and we're cutting it from the raw part. The second one is doing the inner loops, and that's the only one we have. We have a hole in the part, and that's called inner loop. So these are wrapped into different two distinct operations. And the last one is because in the previous tutorial we decided to use the same tool to go over the surface and remove the material and create this reveal. And that is done using the surface milling. It's going to mill the exterior concave faces. So we'll talk about that in future. But right now, I'm just interested in the first operation, which is the outer loop of all parts. So let me extract that from this list with using this list item component and take the first item and connect it to our operation component. So now we only see the toolpath for the outer loop for our rough cut. Now, in order to modify the settings here and improve the quality of this milling, before we actually turn that operation to a toolpad, we're going to adjust some of those settings. And in order to do that, you're going to need a component which is called operation modifier. So that is a component that allows us to extract those parameters from an operation and modify it, and then send it to the simulator again. So now that I have only one type of operation, I can connect it to my modifier, and it should automatically detect what kind of operation is it, and therefore changes the icon of the grasshopper component. So this stands for 2D contouring. So that means that we're dealing with a 2D parallel contouring, and for that I'm going to just free up some space here because that's a pretty large component when we open it. Okay, so we have two groups of settings here. One has to do with the strategy, and the other one it's holding the settings for lead and links, where your tool is engaged or retract from the material or goes from one operation to another. We're going to talk about that in the next video. We're just going to focus on this part now. And under the strategy, you can see that you have the contours. The first option where basically sets how the contour should compensate for the tool radius. And here you have three options. You can go right where the pad is. You can go inside the pad or offset inside the pad or outside the pad. Right now it's automatically selected for the outside, and that's why you go around these parts. If I change it to the inner pad, is going to change to the inside. I need to obviously use that in the simulator. So now you can see that that has gone completely inside the part. So that's obviously wrong. So we will use the default setting, which was correct. And then you have a start point, which allow you to change where the tool engage with the material. For example, now at this point you have, let me see it in perspective. So you can see that at this part, your tool will actually dive into the material at this point. You can shift that if you like. So obviously it's going to do that for all of the parts here. Honestly, I prefer to start somewhere here rather than in the corner. So I think that looks good. And then there is an offset which will which will offset the tool pad away from the part. We don't really need this because we already have set 1 mm offset in our rough milling, and that's a 2 mm offset. So I'll leave that to default setting, and that is all about the contour setting. Now the next thing we're going to do is to update our depth of cut, which is a very important parameter in the milling. You have three ways of setting your depth of cut. The depth of cut basically means how much material or how deep you're going to dive into material in every pass or in every step which you move the tool into the material. So at the moment we only have one pass, and that means that we are going through the material with a 12 mm deep, which is actually the thickness of our material. So we're cutting all the material in one go, and that is most of the time not a good idea. Although this is a rough cut, maybe it's fine if you have a really strong tool. But I'm going to just make it in 2 passes. And for that, I can either set the depth of cut to 6 mm, um, which will be the half of the material thickness. Now, if I zoom over here, you can see that I have 2 passes, one at 6 mm and the other one at the bottom of the part. I can also set that by number of passes, so I can decide, like, I'll go with the 2 passes or 3 passes and so on. And you can also do it by a percentage of your material. So I can say, okay, I'm going to do it by 50% of the material thickness. So all of that is possible. It depends really on your preferences. The next option is called Z Cleanup, and it allows you to create an extra pass right above or below the bottom plane or below the bottom of the part. So it works like this, that if you provide a positive offset, you're going to have, for example, let it to be a 1.5 mm or 1.3 mm. I am getting an extra pass 1.3 mm above the bottom of the part or above the last pass, because we still have a pass that it goes right at the bottom plane. And you may find this useful because usually when you do a fine milling, you probably want to go with a very minimum cut at the with the last pass in order to minimize the damage on the material. Or you probably have a big sheet of material and you don't want the your part to be detached suddenly from the sheet, and then it could be that the sheet moves on the table or something. So you want to keep a little bit of material until the last pass. So that there are other usages that I may not be aware, but that's an option that many CAM software provides. So and we can also give a negative number that basically pushes the last pass a little bit below the bottom plane, and This will ensure the material is completely cut from the sheet or the raw part. I personally use these usually with a negative number because it takes care of any tolerances that my sheet can have with respect to the horizontal plane. So sometimes your sheet is not completely in the same plane. It has a little bit of deviation from this bottom plane, and therefore you might miss some parts at some point where the sheet's a little bit higher. So just to ensure that going through this entire depth of material, I most of the time give a minus millimeter, 1 millimeter or minus 0.5 millimeter here in the Z cleanup. The next thing is the finish pass, and this will actually does the same as Z cleanup, but in a horizontal plane. So if I increase the finish pass, I'm going to get an extra pass which is offset from my original pass in outward direction. Um, this is good most of the time for fine cutting, where your drill first goes on the outer pass, and then it's going to go. Let me just play the simulation. So at this point, we can see now the drill is going over this pass, which is the outer one. And once this finish, let's go faster a little bit. Now it's come back and let's stop. It has come back to the inner part. Oh no, I have two passes, so it's still going down. Uh, it's still going down to the next pass. So let it go. So now I believe it's on the inner pass. Yes, now it has gone to the inner pass, and it's good because if you have really good quality, of course this is a rough cut, so for us it really doesn't matter because we still have 2 millimeter here from the actual part. But if this was a fine cut, I probably wanted to do another an extra pass as a finish pass to make sure your surface will achieve the quality that you want. So basically these are the settings for your depth of cut, and we're going to talk about the corners and machining strategy in the next video. So please keep in touch and see you in the next video. Thanks for watching.